So there was some concerns with your classmates if you're tuning in a little later. This is based on problem number 7. If we have 310 grams of calcium hydroxide, how much of out of that entire compound, how much oxygen is in 310 grams of calcium hydroxide? All right, so if we have grams of calcium hydroxide, how do we cancel that out? And where does that moles go then?
You put the atomic mass on the bottom.
Okay, so for grams of calcium hydroxide, that's what CH means, it's not carbon and hydrogen. And we have calcium hydroxide right here, okay? So it's a mole of calcium hydroxide, okay? So we must have to be putting a number here, which would be correct. The atomic mass for calcium is what, about 40?
40.1.
Oh, 0.1, okay.
Yeah, it goes 7, 8.
40.10. Okay. Then how many calciums do we have?
1.
Okay. So oxygen 16, right? And we've got 2. And then how much do we have for the hydrogens? Okay. Okay, so 74.12. That's all of that added together. Now, that's of this entire compound, but remember, we're just looking for the oxygen. So this next step is really critical because it allows us to change what it is that we have into what it is we're looking for. Just like if you're making that conversion from feet to inches, inches to feet, miles to feet, for instance. You're using dimensional analysis. In this step, we can get rid of this moles of calcium hydroxide. And how would we do that? Moles of calcium hydroxide on the bottom, which is what we have. Moles of oxygen. Okay? Because again, that's why we put a box around it, because that's what we're looking for. And how many moles of calcium hydroxide do we have?
None, they're canceled.
Just 1. Okay, because there's a 1 here. And then, now what about your oxygen? There's 2 here. Okay, so everything has canceled so far. Now we're in moles of oxygen, so that's not going to answer how much of this mass is in oxygen, because we're in moles.
1.01.
Not 1.01. So moles of oxygen.
That's 1.008. That is 12.01 grams of,
Where are we getting carbon from? Where are we getting hydrogen from? Okay. Okay. So are we done converting everything? Yes, because we're looking for the mass of oxygen. Because we started with 310 grams of this entire compound. Now we've just isolated it to the oxygen, and that's what we're looking for. Okay, so how many numbers are you multiplying across the top?
3.
Okay, and then your final step is dividing by 74.12. And that would give you the amount of oxygen in here. And I don't think there's any percent compositions on there. Is that correct? Does it say what is the percent composition of this element in a compound? No, and that would not be difficult to compute, because maybe we're going to say this is somewhere around, so I don't know, I'm just going to say 21 grams. I don't know if that's right or not. I just pulled that number out of the air. So then if this was a percent composition, it's not that difficult to say, well, if there's 21 grams of this, what's the percent composition? Well, you'd have 21 divided by 310, because 310 is what you started with, and we already calculated that maybe there's 21 grams in that, and that would give you your percent composition.
So then would calcium calcium nitrate be Ca, and then the nitrate, there'd be 2 of them?
There would be 2 of them. That's correct.
So,
Okay. So, you still have about, we'll say 30. I have empirical formulas on there, but I'm getting the input that we're not ready to start that yet. That is new material.
Could you put like a couple examples on the board and like the people that are done with their worksheet like work on them? Yeah.
Unhit pause now. There was some concerns that maybe we need a little more practice, and that's fine. This is based off of, this is just one extra added step. It's really no different than saying, what is the amount of zinc in 410 grams of zinc chloride? Now you're just saying, well, what's the percentage of that when you find that in a molar mass problem? So the first things first, we need to be able to write out what is the formula for zinc chloride. Zn Cl2. Okay, so in this case, we're starting with 410 grams of this entire compound. We want to know what's the percent of zinc in 410 grams of zinc chloride. Okay, you start the problem in the same manner with 410. This one's short enough that it's probably not that big of a deal just to write out your formula. Or you could put ZC if you wanted to, because that's zinc chloride. That would work too. Okay.
30.
Now, what is our first step then?
Atomic mass on the bottom.
Okay, so grams of zinc chloride go down here, then moles of zinc chloride go up on top. So then we have to be able to put a number here. So the atomic mass of zinc is 65? 0.38, okay? And then chlorine is 35.45, right? And then you add that together. And I really don't need to do the math, because sometimes when you've done something so many times, it's kind of like going to your place of residence. Someone says, well, what's your address? Well, I really don't know what my address is. I just go there, okay? And maybe that's not the case. But anyway, so we add these together, the 65 coming from the zinc, the 70 coming from the atomic mass of zinc multiplied by 2. That gives us 8. Then we've got 12, 1, 6, and then 136.28 goes here. Okay? So we're in moles of zinc chloride, but that's of the entire compound. This third step is important. This is step 1. This is step 2. Why is that third step so important?
That changes from moles of zinc chloride to moles of zinc.
Yeah, you can change what it is you're looking for, which is we want moles of zinc and changing it from what we have, which is zinc chloride. So these have canceled. How do we get rid of this mole of zinc chloride? Moles of zinc chloride go on the bottom. And what is it that we're looking for? Just moles of zinc. Okay. Then these have canceled. Now we need to find the mass of zinc in that problem.
65.3.
Okay. So 65.38. Nope. Oh, I thought I heard the bottom. Okay. 65.38 grams of zinc is what you get for every mole of zinc. Notice they're gone. Okay. So then, once we get that answer, then we'll tell you where the percent composition comes from. So 410 times 65.38 0.38. And then notice we didn't put a number here because there is only one. Every other problem that we've done, we've had to add a little subscript. Like if it was 2, well then we'd have 70 here, or excuse me, we'd have 35.45, then we'd have a little 2 there. Okay, so 410 times that, then divide that by 136.28. That give you 196.70. Now, that's grams of zinc, but that's not what the question is asking though, is it? So, excuse me. So we have 196 grams of zinc, but now, this is you got a 50-50 chance, and we have not learned this yet.
196 over 136?
Yeah.
You would think so,
You
but
go
that's
190
not quite the case.
You would put it over 410, right?
You would put it over 410, because you want to put that over what you started with. This is just the molar mass of all of that together, because we want to know the atomic mass of what we started with, okay? So, upon doing that, that means 196.7
0.48.
divided by 410.
So that'd be 48%.
That would be 48%. So 48% of this compound is composed of zinc. Of course, it came out as 0.479, so we round that up to 0.48, which then means that is 48%. So, yes, it's a new problem, but what you're doing is you're still approaching this in the same manner, same process that we've been doing, but it's just that one extra added step. We're closing the books on this, and again, as you can see, it's just this one extra added step. We're still requesting one more example. So we had a little bit of student input here in saying, what is the amount of sulfur? Yes, yes, amount of sulfur in 400 grams of iron 3 sulfate. So the first thing we need to do, what is the formula for iron 3 sulfate? Okay, now the sulfate ion. Okay, go by your negative ions. This has a charge of what? Okay, what does the iron have for a charge? Okay, if it was iron 2, we would be done. But if we got iron 3, then
3 sulfates and 2 iron.
right, because the least common multiple is what?
6.
And there's nothing wrong with doing this. If this is what you need to do to feel more comfortable to get your subscripts, 6 divided by 2 is what?
3.
That's where that 3 comes from. 6 divided by 3?
2.
There we go. Okay. So now we got our formula. And it said, what is the amount of sulfur? So we'll put not that you have to do this, but then we can go back and say, well, we're talking about sulfur here in this compound. Okay. So how do we start this problem? What's our beginning mass?
400 grams.
400. See, we're answering these questions like we know what we're doing. So are we just wasting time? And that's fine. We're not wasting time? Okay. 400 grams of, and now since we have that wrote down over there, there's nothing wrong with writing iron sulfate. You have to know that this is standing for that. The reason we didn't do that for zinc chloride is look at the difference and how much longer this formula is than this one. Okay, so how do we get rid of the iron sulfate? Okay, so then grams of iron 3 sulfate, we get a mole of iron 3 sulfate. All right, So iron has an atomic mass of
55.84 or 85.
okay. Then how many of them do we have?
2.
Okay, the atomic mass of sulfur.
32.4.
Isn't it? Is it 1?
It's 0.66.
Oh, I thought it was 32.06. Okay. .10. And how many sulfurs do we have?
3.
Trace of them. Yes.
So notice we're accounting for each and every one of these. And then how many oxygens do we have?
12.
Okay, so we can just take 12 times 16, because 16 is the atomic mass of 1 oxygen. So that gives us 192. And then when we add all that together, so 55.85 times 2 is 111.70 plus, well, 111.70. Then 32.10 times 3, that gives you 96.30. There's your sulfurs, and then there's our oxygen. Okay, so plus 111.7 plus 96.30. You get 304.
I got 400. Not sure how.
Okay, I might have punched that in wrong. 192 plus 96.3 plus 111.7. 400, you're right. I must have missed something. Huh. Boy, this is going to be a funny looking problem.
Yeah.
Okay. So now we're in our third step. And why is this step so critical? We can change what we have, which is what?
Moles. Wait.
Okay. Moles of iron sulfide, or iron sulfate. And we're going to change that to moles of
Oxygen.
Sulfate.
Sorry.
sulfur.
Sulfur.
That's all we're
Okay. So then in this step, how many moles of sulfur do we have?
3.
We only have 3. Because if it was oxygen, we would have 12 there. And if it was iron, we'd have 2, but we distribute that 3 for the moles of sulfur. All right. So now we're on the home stretch. So for every mole of sulfur, looks to me like we get 32.10 grams of sulfur. Okay, so 32 times 3. That's really all you got to do, because these two cancel each other out. That's why we said, oh, this will be interesting. 3 times 32.1, 96.3 grams of sulfur. So what if we wanted to find the percent composition of sulfur? There's just that one extra added step.
It would do. It'd be the same, wouldn't it? It'd be over 400.
96.30 divided by 400, and that would give you the percent composition of sulfur in that compound. Okay. Okay, so hopefully we're adding some understanding to this. I'm getting the, I don't want to say vibe, but I'm getting the feeling that we're just not quite comfortable with this yet. So if that's the case, continue to work on this and turn these in tomorrow. All right? All right, so we'll catch up to you next time. When we start talking about empirical formulas, you're probably going to want to grab a book before you sit down tomorrow. Catch up to you next time.